Rosemary. A new antibiotic is being tested to see how effective it is in killing bacteria. The number n of bacteria on a slide t minutes after a controlled amount of the antibiotic is added is given by this. So pretty much the formula you're interested in is this. Show that the number of bacteria on the slide decreases at a rate proportional to the number present. Okay, what did we learn last week? What does rate mean? Pretty much. What does rate mean? What was step one usually? To do what?
Differentiate.
To differentiate it, right? So we wanted to find that dn on dt, maybe we should do it from the beginning one more time. We wanted to find that dn on dt, when you differentiate this, you bring the k down, so it becomes k and naught, bring the k down, k and naught, and you keep it the same, ekt. So dn on dt, or n dash, is the same as k and ekt, and n naught ekt is n. Right, so this bit here is n. So the answer is just k n. So you can tell that it's proportional, k is just proportionality, to the number present. So the same thing with this one, dn on dt, you just differentiate that. So differentiate that, you just bring this down. So 2000 times negative 0.099 is negative 198. And then E negative 0.099t. And you can tell that the number of bacteria on the slide is decreasing, see, negative, at a rate proportional to the number present. So decreasing at a rate proportional, which means just a letter K, to the number present. The number present was E negative 0.999t, sorry, which is n over 2000. N over 2000. Right, so E, you got to solve for E. You got to bring this guy over to here. So therefore, E negative 0.99 t is equal to n over 2000. So you're done, really. I'm just n over 2000. Therefore, bacteria decreases at a rate. Bacteria decreases at a rate proportional, so it's a negative 198 over 2000, proportional to the number present. Number present was questions there? So you always want to get back to n. Okay.
Yeah, sorry, but Sam, wait, where did you get the 198?
So I just did it from 2000 times by negative 0.099.
Oh, and then that gave you that.
Yeah, it gave me that.
Okay.
And then with exponential differentiation, we just leave it as exponentials, right? So that's E stays as E. Cool. What is the initial number of bacteria on the slide? What is the initial number of bacteria on the slide? This seems very relevant to what's happening in our world right now, isn't it? Anyways, what is the initial number of bacteria on the slide? What does initial mean? Time equals?
Zero.
Zero. So the initially n equals 2000 e to the power of 0, which is 1. So your answer is just 2000. So initially there's 2000 bacteria. Okay. Triple I. At what rate are the bacteria dying initially? At what rate are the bacteria dying initially? What does it mean to do? What's the key word there? What's the key word? I don't think it's initially. What do you reckon?
Rate.
Rate, and what does that mean?
Differentiate.
So dn on dt. So dn on dt is equal to, you know, you can pick either one. It doesn't really matter. It's the same equation. So let's just say we pick the second one. Negative 198. What is n initially?
Video uploaded.
2000. So 2000 over 2000 is 1, which is negative 198.
Hey Sam, I'm having difficulty understanding what's going on. I'll just watch the video. Year 11 advanced, and if I have questions, I'll let you know.
Okay, that's fine. Negative 198.
Hey Sam, I'm having difficulties understanding what's going on. I'll just watch the video you uploaded on Year 11.
All good. All good. I heard you. IV. Find the time taken for the number of bacteria to halve. Find the time taken for the number of bacteria to halve. How would you work that out? Find the time taken for the number of bacteria to halve. Come on. What would I let n equal to? 1,000? No, 1,000, right? Half of 2,000. So you initially started with 2,000 bacteria, now you're down to 1,000 bacteria. Okay, now what do? We're trying to solve for t. So you divide by 2,000. 1,000 divided by 2,000 is a half. Log both sides. Aya, did that all make sense?
Yeah, that makes sense.
So n is 1,000, divide it, log both sides. This power comes down when you log it, you get rid of your e, and then you divide and sub it in to your calculator and you're done. Cool. That was worth 4 marks apparently in this particular exam. Oh, answer to the nearest minute. I would have lost a mark. So 7 hours and 0 minutes. Now, if you didn't write 0 minutes, you will not get full marks. So you're going to write 7 hours and 0 minutes. No, it sounds silly. That's just how it is, isn't it? V. Sketch a graph of the number of bacteria present against the time during the first half hour. Wait, sorry, are these in minutes? T's already in minutes. My bad. Go up. If T's in minutes, then this is 7 minutes. V. Sketch a graph of the number of bacteria present against during the time for the first half hour. Okay. There's your time. There's your number of bacteria. Initially, when time is 0, it's at 2000. You should know pretty much how this curve would look, right? It's an exponential that's negative on the power. So looks like that. Now it does say for the first half an hour, so that's at 0. You got to sub in t equals to 30, and all we want to see is just the answer that became. So when t is 30, just sub in t equals 30, so you get n equals 2000, e negative 0.9 times 30, e negative 0.099 times 30, yep, times 2000 is 102 or 103 rounded. So in 30 minutes, there's only 103 bacteria left. And that's pretty much what we would have liked to see. Okay, and last one, VI. What does it say? The antibiotic is considered effective if it kills at least 99% of the bacteria on the slide within 1 hour. Is this antibiotic considered effective? Explain your answer carefully. All right, what do you think we're going to do? If it kills at least 99% of the bacteria on the slide within 1 hour, what do you think I'm going to let n equal to? What would I let n equal to? Where n stands for number of bacteria on the slide. What would I let n equal to? Any ideas?
$20.
What's your reason?
Hello?
Sorry?
Hello? Oh, you can hear me?
Yeah. What's your reason?
So 2000 times 0.01, which is that 1% of the bacteria.
I like it. So let n equal to 20, which is 1% of the bacteria. Solve for t, and if t obviously gives us greater than 60 minutes, then it's a problem. If he gives us less than 60 minutes, that's great. That means we can get to 20 in less than an hour. Oh, sorry, that was meant to be a 2000 in front of it, wasn't it? 2000 e negative 0.099 t. All right, beautiful. So we'll just do the same thing again. 20 over 2000. I think you guys, if you remember this from last week, it starts to get pretty repetitive once you get used to the work. You log both sides, divide by this guy, divide by negative 0. So it looks like log 0.01 over negative 0.099. Let's plug it in. Log this divided by this. we get 47 minutes pretty much. So yes, it's effective. Simple. All right. Good job, Andy. Any questions about that? Let's see, how many marks was this? 8, 11 plus 4, 15 marks. All right. 15 marks. Crazy. But there you go. Oh, I had all this lined paper I didn't use. That one seems easy. HSC. Yeah, let's do that one. All right. I'll give you guys maybe just again a few minutes just to write a few things down, have a think about it, what it's saying. So when I start, you know what I'm doing, and then if you've got any questions, you can actually ask me. All right, let's have a look at this. A rare species of bird lives only on a remote island. A mathematical model predicts that the bird population is given by this. From last week, we also remember this can also be called Newton's laws of cooling, right? Because there's an extra term. And the only idea with Newton's laws of cooling is that there's constant air temperature surrounding the body. But for now, that's okay. You can just look at it as it's just saying it's this thing. Where T is the number of years after observations began. Okay, according to the model, how many birds were there when observations began? What do I do? Stefan, what would you do with I? According to the model, how many birds P were there when observations began? What does that mean?
So in the beginning.
Yep. So what would you sub in? Time. What do you know about time?
Time. It's minus 0.05.
No, it doesn't. It's not working like that. All right. So this is a model, right? So this allows you to find the bird population at any given time. Cool?
Yeah.
When it first began, what would you assume time to be?
0.
Yeah, that's the idea. So initially, and when it first began, whatever is time is 0. So how many birds were there? There was 150 plus 300 times technically 1, which equals to 450. According to the model, what will be the rate of change in the bird population? All right. Anyone have any idea of how they would do double I?
Well, as time grows, the exponential will grow.
Well, if it was a positive exponential, you're right, but this is a negative. So as time grows, this is actually growing, getting smaller. Technically, so it's actually they're losing. They're dying out pretty much. They're becoming extinct. Sorry. Azra, any ideas? According to the model, what will be the rate of change in the bird population 10 years after observations began?
Would you differentiate?
Okay, and then when I do differentiate, because that is a rate of change, and then what? So you brought the negative down, you times it by. Yep, I've differentiated. And then according to the model, what will be the rate of change? That's the rate of change in the bird population 10 years after observations began. What would you do? Literally a line away.
Sub t equals 10.
Yeah, simple. Sub in t equals 10. Stefan, see how simple that was? So the key word there was more the rate of change. To know rate of change is differentiate. Or rate. If you're ever seeing a rate, it means differentiate. D, P on dt. And then differentiate it. And then obviously saying after 10 years, sub in 10. E to the answer times negative 15. That means by the 10th year, you're pretty much losing 9.1 birds. That's how you interpret this for each time, like for each number of years, let's say. So each year, and by the 10th year, sorry, you're losing 9.1 birds per year. Okay, triple I. What does the model predict will be the limiting value of the bird population? That means another way to say that is, eventually, or eventual value, or eventually, what would be the bird population? What am I looking for you guys to say? Eventually, limiting value. What's its maximum limit? T equals what? Come on, I'm sure some of us think about it. Say it. Say it again.
Infinity.
Yep. So eventually, it means time eventually goes to infinity, which is dp on dt equals through 150. Sorry, what am I doing? Y dp on dt. P equals population 150 plus 300 e negative 0.05 times infinity. All right, what's a negative number times by infinity? That's obviously still negative infinity, right? This bit here is still e negative infinity. What does e to the power of negative infinity become?
0.
What's 300 times 0?
0.
So the answer is just 150 as t approaches infinity. So eventually the population will die out to about 150 only. And we did a question like that again last week. So you're seeing they're very common. Infinity questions are very common with your exponentials because they work out to always be 0. The species become eligible for inclusion in the endangered species list when the population falls below 200. When does the model predict that this will occur? Okay. What do I do? What do I do for this IV? Come on, quick. Greg, what would you do? Species will become eligible for inclusion in endangered species if the population falls below 200. When does the model predict that this will occur?
So I would make it equal to, like, P equal 200.
P equal 200, and obviously what letter would you solve for?
You would solve for T.
Done. Exactly like the question we just did above with Andy had said. It's pretty much the same idea. Instead of that bacteria, we're doing it for same idea but with the bird population being at 200, and just trying to work out when that happens.
Yeah.
Negative 0.05 T. Subtract 150, divide by 300. Maybe you can do that in one line as you guys get better and better at it. Take away 150, divide 300. That becomes what, 1 on 6. You would log both sides.
Yep.
And you would bring this down. So your answer looks like this. Log both sides. Bring this guy down. And then divide. And that is the time. Easy. Log 1 over 6 over negative 0.05. 35.8, 36. So what, 36 what? 36 years. When does the model predict this will occur? Did they give us a year they began with? Nope. 36 years. In the 36th year. It will go below. All right. One more. This one here, it's exactly what we've done. But the reason why it's worth a whole solid 5 marks is because they haven't broken it down into part A, part B, part C, part D. They're just going to make you do it, find the straight away yourself, and that's why the whole thing's just worth 5 marks. So we will do that. I just want to see. Okay. Yeah, that's pretty much where I wanted to get to for that bit. Again, maybe have a read first. You've already got the equation there. You have to always try to see if you can find NO and K first. That's just a golden rule that you want to remember. I think I can see that it says that anyways. But you have to find NO and K, and usually that's found from the first 2 pieces of information. And then once you've got that, you'll have your equation, and then you can work out the number of koalas that will be present in November 2021. But have a read anyways. See if you can. And again, we'll do. Actually, you're going to do it with me, so maybe have a good read of it, and then we'll get started together. Okay, Aya, are you ready to start, or just a bit longer? You want to have a think about it a bit more? Or... Let's start it. All right. So let's do this. So the first thing I've got is n equals n naught e kt. You know we need to find n naught and kt. It says in November 1923, 18 koalas were introduced on Kangaroo Island. By November 1993, the number of koalas had increased to 5,000. Blah, 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 in years from November 1923. Find N and K and predict the number of koalas that were present in November 2001. Okay, that means when time was what? N equals... Any idea? It's not 1923.
When time is 0?
Yeah, that's the idea. When time, it will adjust at the beginning, because that's always, every single question, it's going to work like that. But time is at the beginning, your number of koalas were 18. When time is what?
7?
Now, yes.
That'll be
N is 5,000. So the first thing we're going to do, this one's going to let you find K, just so you get used to this. This one will always find N naught. So, but let's see, we'll just sub them in, right? So N is 18. This one still stays. E, you know, T is 0. 0 times K is 0. E to the 0 is 1. Well, you just found 18 for N naught. So now your new equation becomes 18 E KT. You also know that N is 5,000 equals 18 E, and then what do I write?
A70?
K70. Oh, K70, sorry. 70K.
Yeah, sorry.
Yeah. All right, and then now we want to solve for K.
So bring the 70 down.
Ooh, not yet. This one here.
Divided by 18.
So it'll be 5,000 over 18 equals E70K. Now you want to, what both sides?
Log.
Yeah, you got to log both sides. Then you're allowed to bring this 70K, because log of E just cancels out.
Yeah.
So technically you have that over that equals 70K, and then you're going to divide by
7.
Plug all that into your calculator. Let's get an answer. Log. What'd you get?
0.08.
And usually write it to like 4 decimal places.
Okay.
But what are you going to do with that K? Shift store A. Right? Store is on the RCL button, which is on top of 7.
Oh.
It
And then
says STO in yellow. Shift store and then press the bracket like that, which is A. And your calculator should say answer.
yeah, and I press equals. Or just
Shift
leave
store A. And no, that's it. Just leave
Oh.
it. Press AC now. AC. Just clear it. Gone.
Okay.
The reason why I say that is because you've got to make sure here you've rounded. You
Yeah.
can't use this rounded answer.
Yeah.
Okay, so we just write that. You got your marks. Now, and predict. Well, hold on. So now your new equation is this. 18 E K, where that K is this. T. Predict the number of koalas that will be present on Kangaroo Island in November 2001. What does that mean in terms of for the time? What time would that be? So you got to work that out. 2001, take away 1923. Time is 78. Look how easy that was for 5 marks. Something that we've been doing day in, day out, day in, day out. Same question. Bang, 78. I want you to put this exact, wait. I will put this in my calculator. I want you to put it with the Shift Store A, the capital A answer. Do you know how to bring A back in?
Do I just click alpha A?
You press alpha A. Yeah, perfect. So you're going to do 18E. Yours is going to look like this in your calculator. A times 78. I'm going to put this in there and see what answer I get and what answer you get. It might have not mattered. We'll find out together. I got 9524.
I got 9511.
Nah,
Right.
that really. All right, there you go.
Can you check if I did it right?
Fair enough. 18 E capital A times. Yep, that's right. Yeah. Well, yeah, 9512 actually when you round.
Yeah.
Yeah. So look what difference that makes. 12. 12 kangaroos difference. So you can't use a round answer. Just you guys got to get used to that, especially with exponentials. Like it didn't matter so much when you're in year 9 and 10 and using lines and let's say parabolas. But once you get to logs and exponentials and trigs and stuff, it makes a world of difference. So don't. You have to use it like this. Must be exact. Otherwise, what a waste. You would have got 4 marks out of 5. Cool. Good stuff, That was good. And that's pretty much what you need to know. Exactly what we did is everything you want to know. And then the key word, if it comes up, is rate, just means differentiate. Just keep that in mind. But I think I'm pretty happy with that. I just want to see if there's anything else here that I want to do right now. No, this is not for us right now. Won't be till next year. All right, now go to rates of change, which I would not use this booklet. All right, any questions about exponential growth and decay? Should I do some more Newtons? Oh, not yet. I think we'll go back to rates. So that was probably our harder one. I did those two. We're up to question 3. Should be all right. Question 3. The area of an equilateral triangle is increasing. Okay, let's screenshot that. Okay. Then, after exponential growth and decay, the next bit you need to know, and the last bit of pretty much rates of change, is actually what's called rates of change. Now, what you want to remember is this logic. dy on dx can be written as dy on d something times d something on dx. Now these two, as long as they are the same, I am allowed to actually write it like this. Do we agree? Does anyone have any questions? Okay. That dy on ds into 2 other things. If I wanted to, I mean, you could break up dy on ds as dy on dh times dh on ds times ds on dx. Does that all work out to give you dy on dx? Yes, no, I'm confused. Okay, so we can see DH can cancel out, DS can cancel out, you're back to dy dx. The reason why you would want to do stuff like that is in case you didn't have this, but you did have this, and you did have this. Well, then if you didn't have this, you'll need to break it up again, and then you'll be able to continue. We're going to look at these styles of questions today, as well as your basic ones. But I didn't get to make that point last week. Okay. And I'm going to also tell you another way of actually reading these that I didn't say last week. So, first bit does say the equilateral, the area of an equilateral triangle of side x is increasing at a rate of 5 centimeters squared per second. Show that the area of a triangle is given by this. So the area of the triangle is given by this. So that's got nothing to do with rate. So how do I start with A? So the area of a triangle is given by this. Come on. Area of a triangle.
Area of a triangle is in that half times base times 5.
It's equilateral. How do we find this? Area equals half times, what's the formula? Sine C. Half AB sine C. Half times x times x times sine 60 degrees. Sine 60 is root 3 on 2. I think we got it. Root 3 on 2 times 2 is 4x squared. Anyone hasn't seen this formula before? All right, so just memory. Half AB sine C. And I think you guys probably remember me saying this before we started rates of change here. I said the problem with this compared to exponential growth and decay, all of your growth and decay questions are pretty much the same. Your rates of change, every single one's different. And I said you're not going to feel comfortable with rates of change until you pretty much do, like, I don't know, all the questions that are out there, you will say, I'm comfortable with rates. So this one takes a lot of time. If I could give you any topic you want to invest all the time you've got in, it's this topic here. You can see it involved trig all of a sudden, or it has everything. So you really want to work on rates of change. You don't want to neglect this topic. Find the exact rate of increase of the side length when the triangle has side length 15. Okay, so what am I trying to find? D what?
S.
Yep, S stands for side length, so ds on D.
X.
Rate, just so it makes it a bit easier for you. Rate is usually going to do with time, most of the time, or like, in fact, all the time. If it's a rate, unless specified otherwise, let's just say that. So all the time, unless mentioned somehow otherwise, it's going to be ds on dt. Cool?
Yeah.
All right, so good job. That's ds on dt. That can be broken down into ds on something times something on dt. And obviously now we're missing this this letter, D of what? What is it going to be? And that's when they gave it to you at the top. So who's going to give me the letter for this? The area of an equilateral triangle of side is increasing at a rate of this 5 centimeters squared per second. We know it's D because it's a rate, but who wants to say the letter? D what? What is this? How do we read this? dx? No. No. Good try. And that's the trick that I was... Oh, sorry? What? Say it again. I can't hear it.
C?
C? Is what you're saying?
Yeah, is that wrong?
No, not DC. Good
It's
try.
A because of area.
Ah, yes. It is A because of area. And how do you know that other than area? What's the... I'm about to give you guys a trick. Do you feel like you know it from another way?
Because the question says area like 3 times.
Fair enough. It's not that, it's actually this. So what you guys haven't realized, obviously we haven't put together yet, is when you've done, speed, kilometers per hour, that was distance over time. Distance over time, you obviously, you got taught it's speed. But speed is the derivative, the change in your displacement with respect to time, right? We'll learn this more next year, but I'm just trying to say, right? Speed is the change. D is just a change in your displacement with respect to time. Now, that became kilometers per hour. So the trick is the top unit you'll have in your rates is going to be the I guess the family that this is coming from. And then the same thing with the bottom. If that is in H in this case, well, the family of H's and time and whatever, or minutes, is all with respect to time. So if I was to see this question, I already know that is trying to say dA on dt. If I saw this question, I already know this is trying to say dV on dt, volume. If I saw this question, I already know that's with sides. So I've got to pick, do I want to use X or S's? You got to pick what you want to use for your sides all the time. And then that's what this is saying.
So should we always look to the units?
Correct. That's the trick. That's it. That usually gives it away.
So
Go ahead.
Does that mean we'll only get like those ones that you just wrote?
Well, yeah. Okay. Hold on. No, hold on. So here it is, 24 centimeters cubed per second. So already you know what you're going to do there, dV on dt. This one's a little bit harder. We're going to do it together. But, they gave it to you. dV on dt is negative Ks. It's already given, but we'll get to that one together. Any other ones? I was hoping there was more. No. In 2 units, they give it to you, I think. Yeah, they do. So 2 units are a lot easier. They give it to you. There's no need for a trick there. Anyways, look here. This one says at what rate, right? Liters per hour. Well, you already know what's going to be dV on dt. Here, R meters cubed per minute. What does that mean? Aya?
Would it be dV still?
dV on dt. Volume over time. Yeah, and saying it's at a rate. So you don't even need to know rate so much. Once they give you guys this, you'll know that is a rate anyways. So anyways, cool. But yes, Andy, you're right. It is the unit, and yes, this will be given to you so that you can actually start it off. If it isn't, it's just that it's a little bit harder, which we will do, and you'll see how that kind of works when it's not given to you. Because it's just hidden. So we've got to find that as well. but most of the questions you'll come across have this. So ds on d, well, now we know the letter, it's A and A. So dA on dt, dA on dt is 5, right? So that's already given. dA on dt is equal to 5. That was given in the question. Sweet. That's not even a problem. Times 5. ds on dA. Well, you guys decided to choose S. Whoever said S here, or maybe I did, I can't remember now. But anyways, we chose S. We should have chosen X only because then you would have actually had dA on dx. So I think I'm going to change these to X's so that it doesn't confuse us. X stands for side instead of S for side. So dx on dt, so yeah, dx on dA. Now, I don't have dx on dA. I can find dA on dx. What does dA on dx equal to? If A equals to root 3 on 4x squared, what would dA on dx equal to? Aya, what do you do with dA on dx? D, do you know what dA on dx means? Do you know what this means? It's just a fancy way of writing this, A dash. What if I said differentiate this? Would you know how to do that?
Bring the 2 down.
Yeah. So dA on dx just means differentiate. Bring the 2 down. So that becomes 2 root 3, 4, and then x to the power of what? 1, which is just this. So dA on dx is this. You want to add 15. So what would you do?
You want to add 15.
You want the side length to be 15 centimeters. So you want to find the exact rate when the triangle has side length 15. So you want to at 15 centimeters. What would you do? Because remember, this is everywhere. Y dash or A dash, that's anywhere. If you want it specifically at somewhere, you've got to sub that in. Two times 15 is 30. 30 on 4 is 7.5. So something like this. And then dx on dA is what? If I found dA on dx, it's this. How would I write dx on dA? Reciprocal. So reciprocal of this guy. Times by 5. Plug it into your calculator and you guys are done. I think we've got to do some more. I still feel like you guys are lost. Am I right? With that? Yeah? Are you still confused?
I get it, but it's not like.
Yeah, it's not 100.
Yeah.
It's not even 70, is it?
Yeah, I give it like a 60.
I like it. You're just using the numbers like I am. All right, let's go. That's B. We'll do some more. Let's have a look at another one. Let me have a look at another one. Number 4 is going to confuse you guys. Number 5 is going to confuse you guys. I don't like it. Hold on. Can I make it up? If I make it up, it might not work. And I'm going to stuff it up. It's okay. It's okay. It's okay. I'm going to try one like this. I'll just change it up and we'll go again with something like that. Okay, the rate of increase of a circle's radius is 0.8 meters per second. So again, if I was to see this, what do I know 0.8 equals to? Radius. Andy, what are you going to say? 0.8 equals to D what? On D what? No idea?
No idea.
Okay, meters, radius, meters, dr on D per second, meters per second.
Oh, really?
Yeah, second, S to the N. Wait, is that what you didn't know? Meters second
No, I
negative
knew
1.
that.
Okay. Yeah, that's just meters per second. So, you know, the rate of increase, rate you already know now is D, but you know that because you're like, all right, meters per second means D, dr on dt. Like it's already 0.8.
Okay.
At what rate is the area increasing? So what are you actually trying to look for? Rate, area, D what? Because this first line's the hardest line. The rest should be pretty easy. It's just this first line. Come on, Andy, D what? What are you trying to look for? D? A.
A.
On dt. And then dA on dt is going to be broken into D what? What do you think? D, what letters?
R.
Yeah. And that's why it's really important to recognize this before you get onto this. See, dr on dt, you've got it. Beautiful. dr on dt, that's not an issue. You need dA on dr. Then you'll go, oh yeah, that's just, you know, A with respect to R, which is not a problem because you're doing circle and area. What's the area of a circle?
Pi r squared.
Then what's dA on dr? Well, that means differentiate this one with respect to R. So bring the 2 down, 2 pi r. So dA on dr is 2 pi r. You want the radius to be 1.5. Sub it in. 2 times 1.5. I'll just leave it in exact form. That becomes 3 pi. And you're done. dA on dt equals dA on dr, which is 3 pi, times dr on dt, which is 0.8. Do you get that? The most important step there was this one here, and then knowing that the question says at what rate is the area increasing when the radius is 1.5? Rate area, dA on dt, equals dA on dr times dr on dt. Andy, all good now? Or better? Better now?
Yeah, a bit better.
Okay, let's do another one again. Wait, let me think about it. Rate of increase of circles. Circle. Radius. Yeah.
How did finding that help us with this part?
Wait, hold on.
You can't see my mouse.
Yeah, hold on. You tell me. Wait, let me get my little pointer out. All right, go. Read. What am I reading?
Like when you were just going to it, I got it. But then now that I'm looking at it, I'm like, how did the part you box? No, that's
Yeah, I know that's the problem, but that is exactly the problem I'm trying to say. Like you probably won't recognize that. So the issue that you're saying is the issue I'm worried about. You will have. At what rate?
Sense, but then when you
so because look, the question says the rate of increase, blah, blah, blah. Okay, fair enough. You'll just read it like, yeah, okay, cool. And then at what rate is this area increasing? Okay, I don't get what to do. And instead of us reading it like that, I'm trying to say when you see rate, you're like, all right, that's already differentiation. When you're seeing meters per second, you're seeing radius, you're going, okay, dr on dt is 0.8. The question is asking, what is the rate of the area? So what is dA on dt? And the only way you can find dA on dt is by splitting up dA on dt with dA on, oh, I don't know what letter to pick. Well, this letter here is the letter you've got to pick.
Mm.
And then you go, okay, yep, that's dr on dt. Well, but I don't have this. So I now somehow need a relationship between A and R. And then that's when you go, oh yeah, okay, circle, area, radius, oh yeah, area equals pi r squared. Then you differentiate, and then you sub in your radius, and then you're finished.
Okay, that makes sense.
I'm just trying to see if I can modify it again slightly, but give me some shapes. I don't know why I'm empty with shapes. So there's circles, there's squares, there's triangles. Say it again.
A cone.
Cone. Yeah, that would be good. Cone. Let's do a cone.
IR cubed, right?
Yeah. Now let's do a cone. Okay, give me some more shapes. There's cubes.
A cylinder.
There's cylinder.
Pyramids.
There's what?
Pyramids.
Pyramids. Yeah.
And spheres.
Spheres are good. Oh, sphere's perfect. That's the one I'm looking for. All right, let's do a sphere right now. And then we'll do a cube, we'll do a sphere, then we'll do a triangle. And then from a triangle, we'll get to a cone and then a cylinder. All right. Let's just do all. I think if you guys can wrap your head around this bits, then you'll probably understand the other ones a lot better as well. Okay, what did I say? Sphere. Okay, so sphere has a few things, right? You've got, I don't know. All right, what are the things you've got in a sphere? What are the things you know? Or what are the things that are usually associated with spheres?
Circles.
Yes. And what else? Volumes, radius, surface area. Surface area of a sphere, you know, is 4 pi r squared. You know the volume of a sphere is 4 on 3 pi r cubed. And that's pretty much it. You don't have area of a sphere. So I could say this. This could be the question. You could say the rate of, I don't know. You can do a few things. The rate of the area. Okay, so let's just say, I'll give you so you can imagine it in your head as well. It's a ball, right? So you've got a ball, and you're pumping it, all right? You're pumping it such that it's also increasing. So you can think of it like a balloon. It's a spherical balloon. So as you're increasing it with air, the surface area is increasing as well. Cool. Do we understand that case? Yes. Aya, everybody, make sense? Andy, all good? So yeah. Surface. Okay. So if I said that, I said I'm pumping a balloon, or I'm pumping a ball, whatever, and the surface area is increasing at a rate of 2 millimeters squared per second. You straight away know what? When you're seeing this, what do you know straight away? Someone's got to say it. Come on.
Surface area.
Yeah, but what? What do I know from it? Like, what are you going to write? What's the conclusion you can make from this?
It's going to be dA on dt.
That's it. That's the conclusion you can make straight away. dA on dt equals 2. Cool. Then I might have asked, I don't know, find the rate. The radius is increasing. Find the rate. The radius is, like, the questions can change. You could put, find the rate the volume's increasing, find the rate that it's, like, there's so many different, but they're all going to work the same way. Find the rate the radius is increasing when area, or surface area, I should say. I think you guys get that. Surface area equals, I don't know, 30. Who cares? Whatever, millimeters. Okay. Aya, let's start with you. Find the rate the radius is increasing. So what are you actually looking for? D what on dt?
A.
Say it again.
DA.
dA, no, wrong. You already have dA. Read it again. Find the rate. The, yes. Find the rate the radius is increasing. dr. So how can you write dr on dt? D what?
dr.
dr on?
D something times dt.
Yep. And what do you
A.
think? Yes. But do you have dA on dt?
Yes.
So that's perfect. The only thing you don't have is dr on dA. But do you have a relationship between A and R? Do you know of a relationship between A and R?
Yeah.
Yes. What's the relationship between A and R?
4 pi r squared.
Yeah, you're on the right track. And then dA on dr, because you can't do dr on dA. It's wait. Let's make it clear. You can't do dr on dA. You do dA on dr.
Yeah.
Right? Okay. Equals
Which
2
is
times 4.
A dash, right?
8. Yes, correct.
Pi r.
8 pi r. I said when the surface area is 30, but this time you've got r still. You can't sub in 30 into r. So I made it a little bit tricky. And then, but otherwise, wait. If I make it easy, it would have said when radius equals 30. Cool? If it said radius equals 30, you just sub in 30. Do you agree with that?
Yeah.
And then happy days, like reciprocal, and it should be easy.
Yeah.
But it's not. Can anyone tell me what to do now? The surface
Would
area,
you
or even higher?
rearrange the surface area?
Too easy. So if I gave you surface area is 30, you sub it into here. So you can get 30 equals 4 pi r squared. And you'll just solve for r. That makes sense, doesn't it?
Yeah.
30 on 4 pi square root answer. R has to be 1.5. So the radius is 1.5. They could have said that. Instead, I decided to make it one level harder and say surface area is this. So you got to realize to find the radius. The problem is when they're given questions like this, students actually look at it from the beginning. It's the poor technique, a poor technique to read the question like that. The best technique is to do it the way I'm showing it to you. The rate is you find dA on dt. Rate of the radius, you write dr on dt. Then you already know the letters and you start working it out. Then the last thing is, this bit's here. The surface area is 30. Anyways, 8 times 1.5. I think we're getting it better now. 12 pi. That's dA on dr. dr on dA is 1 on 12 pi. And of course, to finish it off, dr on dt is 1 on 12 pi times what? Times 2. So 1 on 6 pi. That worked out nicely. Andy, what do you reckon? Better? Makes a lot more sense
Yeah,
now?
yeah. 100%.
100. Oh, good. Yeah, that's good. Look, there's key things. I'm trying to really highlight those key things to you guys. I mean, it's the way that someone like me would look at it. It's the way I hope your teachers would be looking at it. You know, we know that that's all we need. That's how we look at it. Rate, radius, and pretty much put it all together. But your first step has to be that. Your second step has to be that. If you're doing it any other ways, you're gonna really hurt yourself because it won't work. Okay, I think I'm happy to move on now. So let's go back and see another question. Question 4. Let's try this one. So this is your cone that you were saying, Ben. And the reason why I wanted to leave them a little bit is because like circles have only 2 variables, right? So like the area and then the radius. Squares have 2 variables, perimeter, area, and then, you know, the sides. Triangles have 3 variables. You know, you've got your area, you've got your base, and then you'll have your height. Cones also have 3 variables. You've got your, you know, area or your volume, and then you have radius and length. Cubes, easy as well because there's only sides. Cylinders have radius and height as well as volume. And then same thing with area. It's got radius, height, and then area. So the ones that have 3 variables are a little bit harder. So I think it's time for that. And see how these work. First, have a read. Try to see if you can put it all together in your head. Maybe write a few things down, what you think you would do. Okay. All right, what do we know? Just tell me the things I know firstly.
Would it be like DC on DT equals 24? Because C for capacity.
Capacity, don't confuse yourself, just use V.
Oh, okay.
We're going to use volume. So dV on dt equals 24. I agree with that. And obviously, what do you want to find is usually the second bit.
The surface area, so dA on dt.
Yeah, so you already know you want to find dA on dt, and you've got dV on dt. So then you're pretty much, your dA on dt is going to be dA on dV, that's weird, times dV on dV. You've got, but dA on dV, why am I saying that's weird? Do you have a relationship between area and volume for, for a cone? Do you have a relationship between area and volume?
No, right?
No, you don't. So what are you going to do with dA on dV? What do you think?
I'm going to split that up.
Yes, you're going to split that up. So that's going to be dA on, what letter do you think?
DH?
Nah, poor choice.
Wait.
Probably going to be R. Because volume of a cone is what? Also, it's got R. Yeah, but it's got H, right? But
Mhm.
the only letters that are the same in both your volume,
Is R.
yeah,
Alright. Fair.
pi r, what's pi r squared h? Yeah, pi r
Yep.
squared h, yep, that's the volume of a cone. So yeah, a little bit harder, you know, that's what I was trying to say. But you will pick up on these as you keep doing more and more. But you know, dV on dt is easy. Andy, Aya, also makes sense. Stefan, dA on dV. Can you guys see how we're saying you can't have a relationship between A and V? So we're thinking that's got to be dA on dr times dr on dV. You get that logic? Okay, so I somehow need a relationship between A and R, and I need a relationship between V and R. Well, I've got a relationship between V and R, but what's stopping me? Come on, what's stopping me? Volume, what's the only thing that's annoying? If you want V and R, you can't have the H there. You guys get that? What does H equal to? A conical vessel is 40 centimeters in radius and 40 centimeters in depth. What does that mean about H? What's the conclusion you can make here? Therefore?
Equals R.
Yeah. The height and the radius are actually the same thing. See how that was sneaky? That's what I'm telling you. Rates of change. You want to spend as much time on this topic. Therefore, H equals R. So your volume is actually 1/3 pi r cubed. And therefore, dV on dr is very easy. You bring the 3 down. 3 times 1/3 is just 1. So just pi r squared. So that means when we're trying to do dr and dV, we just flip it. That's easy. That's technically done. You can put that on the side. Let's do A and R. So again, I've got A equals pi r squared plus pi r L. All right, what don't I like from this one before I can do dA on dr? What don't I like in this equation?
You don't have the L.
The L. Okay, what does L stand for?
The slant height. Right?
Correct. So you've got this and you've got this. How do I find this?
Pythagoras.
Pythagoras. That's how you find your L in terms of R, because your H is R. L squared equals to R squared plus R squared, which is 2R squared. So L equals square root of 2 and then square root of R squared, which is R root 2. Sub that in, pi R squared plus pi R times R root 2. Pi R squared plus pi R squared with a root 2. dr pi r plus 2 root 2, I like to write that at the front, pi r. Ugh. All right. And then it just said the radius is obviously 15. The depth is 15, which means radius is 15. So depth is 15, radius is also 15. Okay, and then it's just a matter of substituting now. 30 pi, just plug it into your calculator. Yeah. There's no point of even doing it like this. Just plug it into your calculator and you should get an answer. But if you want it exact, actually, being extension students, let's do it. R is 15, so 30 pi plus R is 15, so that becomes 30 pi root 2. So dA on dr is 30 pi plus 30 pi root 2 times dr on dv, which is the reciprocal of this. So 1 on pi times r15 squared times dv on dt, which was 24. And then just a matter of putting it together. 24. Don't worry about what I'm doing after this, really. I'm going to just stop and just write it a little bit neater. I'm not going to even expand because it's done. 225 pi. I'm happy with that. You can cross out your pi's, but leave it for now. That's it. Okay. I did say this topic is going to be hard. You don't hear that from me often. So if I say it's hard, it really means it's the topic you want to really master because you can differentiate yourself from your peers. This is that topic. This one will take time. This is probably harder than some of the 4-unit stuff we even do. Those 4-unit kids can probably see that going, oh, it definitely is. It's weirder. It's not, there's no flow, right? It's not like, oh yeah, this line becomes this line because of this, and this line becomes, it's more like, well, now you got to do this, and you got to think of it like this. So now you got to realize radius is the same as depth, so therefore radius is equal to the height. All right. Andy, your 100% went down to 20% again?
Yep.
I know, that's the problem. But it's all right.
It's a bit messy, you know, like.
Yeah. There's no flow. It's like I said, it's fine, but we'll just keep doing it until you guys go, we absolutely get it. There's no point. There's no point of me even moving past rates of change. Because everything in year 12 is based on this. It's calculus just combined. You got to know this really well. Well, the hard bits of year 12 extension 1 especially. Don't want to do that one exactly. Let's just find the simple rates of change. Oh, we'll go to the HSC exams. 2020. Last year's paper. Okay, let's find the rates of change question in here. There it is, 5 marks. Okay, this is a easy one. It's just your exponential growth and decay. So I'm going to give you guys about 5 minutes to go get 5 marks. I believe we can all do this. So that means it should be really easy. All right, there's no dramas there. So go. Last year's HSC paper. Let's go. Ask me if you've got any questions. If you're stuck, You know what you're doing? Just let me know.
Wait, same for the first one, is it where you have to make t 0 first?
What is the number of leaves when t is 31? Do you think you're going to let t equal 0? Yeah.
So it's just 31.
Yeah, of course. And then, what is the rate of change? What are you going to do with that one?
Differentiate.
Differentiate when t equals 31. So then you're going to sub in 31. For what value of t will there be 100 leaves? This becomes 100. You start solving for t. Divide, log. Cool? But yeah, t equals 0 initially. If you ever said it, that's usually to find this number. This number here. I've already found that number for you. So no, you just sub it in. Anyone done with all three?
Yep.
Okay, let's do it then. Let's see if you guys got this. Oh, let's see how many marks. 2, 3, 4, 5. I, like I said, is just a simple substitution. So 200,000. E negative 0.14 times 13. Oh, sorry, 31. If you got 13, you lost a mark. What's the answer to that? Please. No, nobody. 200,000. E negative 0.14 times 31. 2,607.
Wait, Sam,
Yeah.
don't you have to put 31 where the other T is with the L?
Yeah, but what does that do? Does it do anything?
Don't you just divide the T over?
Oh, no. Good one. This is L of. You just did a mistake you've never. You did a mistake you've never done before. F of x, L of t. It's just trying to say L at t days, whatever. Yeah, you understand?
Yeah.
Yeah. Silly mistake. It's fine. Whatever. No, just 2607. The number of leaves at 31 days. That's what L of t means. Okay. What is the rate of change when t is 31? So pretty much we got L dash t equals, bring it down, so 200,000 times negative 0.14 e negative 0.14 t. That's your rate of change, and then at t equals 31, L dash of t equals 200,000. I'm not going to write it. I think you guys get it. Times negative 0.14 e negative 0.14 times 31. Negative 365. Fair enough. You're losing 365 leaves when it's 31 days. Andy, were you able to get double I?
Nah.
What bit confused you?
I just didn't know what to do straight up.
So
But-
as in you didn't know to do differentiation, or you didn't know how to do the differentiation?
No, like I didn't know you had to
You had to,
differentiate for
yeah.
that one.
Yeah. What is the rate of change? So with exponentials, exponential growth and decay, you don't need to do what we were just doing with those rates of change questions above, right? So these ones are going to be different rates of change to your exponential rates of change. The exponential ones are the easy ones. You just differentiate. Basic, like there's no dA on dLt or dt or whatever like that. It's just L dash and that's it. But yeah, that's cool. Triple I, have you got up to triple I yet?
Yeah.
For what value of t are there 100 leaves? So then that's 100 leaves equals 200,000. E negative 0.14 t. Divide 200. And then what do you do after that, Andy?
You log it.
Logged answer, then you would have technically divided by negative 4. Hopefully, you guys got t is 54.29 days. So for what value of t are there 100 leaves on the tree? 54.29 days. If you want to round up, you can't round down, because if you round down, you're going to say 54 days. That wouldn't have become 100 trees. Or 55 days. Cool. Did you get that, actually, Andy?
Yeah.
54.29?
Yeah, I got that.
Cool. So, what? You might be around 3 marks so far. And that's not bad. 3 marks for the HSC. I think we're happy with that. Anybody want me to go through that? Aya, were you able to get the second bit out?
Yeah, that just made sense. It's kind of repetitive.
It is repetitive. It's meant to be repetitive. That's I guess that's math, isn't it? See, that looks repetitive. Bring it to one side, factorize, and start solving. But anyways, differentiate. You bring the 2 down, log. Anyways, all good, all good, all good. Don't want to confuse us right now. Just want to see if there's any. That's a good one for logs and exponentials. But not what I want to do just yet. Yeah, no, that's it. That's the only question I was asked in advanced. In extension, Let's find the rates of change in here.
So all the questions we just did was 2-unit.
That question was the HSC 2-unit paper. The questions we just did, this one here, that's a 3-unit question.
Yeah.
Yeah. But I'm not isolating it for this. I'm not saying it's 2-unit and 3-unit because it's rates of change. And if you understand it, even if you understand it as a 2-unit student, you need to know it this way. You know, so you got to understand it regardless. Yes, the questions might be easier, but like this, I say it's 3-unit, but this has been asked in 2-unit papers as well. It's just that all 3-unit students need to know this. For 2-unit students, only the top students would need to know this, because this would be like a 3-unit question, which means 3-unit kids will be able to do in the 2-unit paper. Does that make sense?
Yeah. That makes
So it's a really advanced 2-unit question.
Yeah.
Yeah. Okay, that's a rates of change question. I'll let you guys think about it. There it is. That's a rate of change worth 3 marks. I will guide you. It does say distance A is inversely proportional to distance B such that A equals 9 over B, where A and B are measured in meters. The two distances vary with respect to time. Distance B is increasing at a rate of 0.2 meters per second. What is the value of dA, the distance at A of dt? So this 0.2 is dB on dt. Do we agree with that? dB on dt is 0.2. It's saying find dA on dt. So Andy, what do you think you're going to write?
dA on dB
Equals, sorry, times.
times dB on dt.
You already have dB on dt. You need dA on dB. Do you have a relationship between A and B somewhere here?
It's inverse.
It does say it right there. A equals 9 over B. So you should be able to differentiate that if you remember your differentiation law. So I'll leave you guys with that just to think about for a few minutes. We'll see if you can get it out. Just be careful. No B's in the denominator. That's it. Okay. A equals 9b to the power of -1. dA on dB equals -9b to the -2. And therefore you get, I don't know, you can leave it like that. What's the problem? It says A is 12. You got to do what we just did before, where we place A as 12 and write 9 over B, 12 times B equals 9, B equals to 9 over 12, sub it in, and it's just a matter of now multiplying it by dB on dt. You're done. Were you guys able to get that out? Was anyone actually able to get it all out?
Yeah.
Yeah? Anyone else? dB on dt, 0.2.
Yeah.
I got it as well.
And for those who couldn't or not sure until they see the last bit, let me know what bit you're stuck with so I know what else I need to work on next week. Like, is it more just a calculus bit so you didn't know to differentiate, or like I need to know exactly which bit so I can work on that. And that's it. What is the value of d and dt? You got 3 marks. Extension 1. You guys got to understand something. This is last year's HSC Extension 1 paper, and you just got 3 marks from the knowledge you have right now. It's amazing. Really, really is. Your 3 in the papers are only out of 84. So 3 out of 84, you got yourself about 4% already in the paper. Easy. HSC's easy. All right. Let's do another one. I can see we've only got a few minutes anyways. You guys got to start doing this, you know, opening up papers. We won't do it maths. We'll do an extension 1 again. We'll see how we go. So open up paper. You know what you're looking for. You know, you'll know what you can and can't answer. Believe me. Like, you'll know polynomials, product of roots, sum of roots. Yes, you should be able to answer that. You might have forgotten, but you probably should be able to answer that. Acute angles, no such thing. You've never done it, so out. This one we haven't been up to it yet, so out. Oh yeah, polynomials again. Okay, what could be the values of, you know, a, b? I'm not going to do it right now. I'm just trying to show you. Look, exponential. We should be able to do that. So this is part of this. The diagram shows the number of penguins on an island at time t. Which equation best represents this graph? I think we can safely say that when time is 0, right? When time is 0, you have to get to this value up here. Do we agree on that? When time is 0, it's going to be this value here, because we know that that is a y-intercept. So when this bit's 0, you got to get this y becoming 3,000. When time is 0, you get 15 plus 15, which is 3,000, so that one can work. 3,000 minus, this one can't work, B is wrong. 3,000 plus 15, that's wrong. 4.5 take away 15, that's 3,000. So it could be D or it could be A. Now you're tossing up between A and D and going, okay, which one is it going to be? Is it going to be the first one or is it going to be this one? Now, is there any ideas? So
It's
think about
D because it's a negative exponential thing.
I don't actually think it's D. I think it's A.
Oh no.
You said negative exponential. How do negative exponentials look like? Aren't negative E? Hold on, let's draw it on the side here.
Okay.
You had it the right way, but you just went for the wrong one. Like, you said negative exponential and you still went for, you know, you went for D, let's say. If it was E negative KT, which is this one here, E negative KT looks like this. plus
Yeah,
1500 means go up 1500.
Oh, the as.
Right? So definitely A. But your one, you said, oh, it's this one because it's a negative. Well,
Okay, just-
negative
yeah.
is this way. If it was negative of that,
Yeah, okay, I see.
you get me?
Yeah, I see.
So
Yeah.
all good. The answer's A, anyways, for that one. Newton's method, out of the syllabus, but you haven't done it anyway. So go on. Acceleration, velocity, in the syllabus. More extension 2 now. But you don't need to worry about it just yet. That's part of mechanics, by the way. But anyways, not yet. Permutations and combinations. 6 men and women are seated around the table. That's an easy question. Anyways, move. Logs, you should be able to do that. See that one? Polynomials can do. Transformations, part of year 12, no. Circuit geometry, no. Consider the functions, find the domain. I should be able to do that. Integration, only 4-unit kids can do that. So using the substitution, there you go. You guys should be able to answer that. Cos squared integration, 4-unit should be able to do that. I think this is a rate of change. Looks like it's a rate of change because it says DH on 20. This is it. See? Look, you could have done all your textbook questions. You probably would have not seen a Ferris wheel question. Exams. You got to do exams. There it is. Here we go. Let's try this one. A Ferris wheel has a radius of 20 meters and is rotating at a rate of 1.5 radians per minute. That radians is just degrees, obviously, but in terms of in terms of radians instead of in terms of degrees. So that's just the angle, and is rotating. So d theta, I'll just write it. D theta on dt is equal to 1.5 radians per minute, just so you guys understand that. But radians is theta. The top of a carriage is h meters above the horizontal diameter. The angle of elevation of the top of from the center of the Ferris wheel is theta. Show that dh on d theta is equal to 20 cos theta. Okay. Well, what's the first thing I would do? The first thing I would do is go dh on d. Oh, probably even easier, actually. I was about to overkill that. I would do opposite over hypotenuse. So sine theta is equal to opposite over hypotenuse. And then I didn't realize you guys can't do that because we haven't done differentiation of this. So I'm going to not do this anymore, except I'll just quickly show how easy it is to the 4-unit kids who know to differentiate trig. H equals 20 sine theta, dh on d theta equals 20. Derivative of sine is just cos. But we can't do it because I just realized it's going to involve trig. Damn it. Inverse, that would be good. You can do that, but not part of this topic, so we're not. Induction, more inverses, which you can do. No more rates of change. Projectile, part of 4-unit now. No more part of 3-unit. Binomial and binomial probability. End of paper. Okay, never mind. Let's go with an advanced one. I think there'll be one easy, quick one in the advanced paper. Oh, whatever. We'll just use 2011. Doesn't matter. All right. Rates of change. There's your exponential growth and decay worth 5 marks. See, find K, always is. And then find the time of day when the object is 37. So now that you know T is 37, I'm guessing A and B might be very similar to 5 and 25 or something close to it. K is the same constant, and then you just got to solve for T. Such an easy question. All right, it would be that, but I can tell that's going to be way too hard for us to do. Right now, it's a shame. All right, next week I'll get all our rates of change questions. I wanted to do an advanced one real quick, but I'm not going to be able to get back, can I? No. Gotta go bloody Nessa home. Who does that? What an annoying website. Don't worry about it. Let me stop this recording firstly.